This is how to wire an isolator switch, the disconnect that lets you cut the power stone dead before you work on it. Supply in on the top. Load out the bottom. A double pole switch that breaks the live and the neutral together. And a hasp you can padlock in the off position. It is a simple device. Let me show you every terminal, then draw one live. So what is an isolator? A disconnect switch. Actually for one job, to safely cut every supply conductor at once, so everything downstream goes dead and can be worked on. It is not there to switch a load on and off day to day. A normal switch does that. An isolator is the thing you throw before you open a geyser, an aircon unit, or a distribution board. Open it, and the whole circuit past it is isolated. Dead. Safe to touch, once you have proven it with a tester. That is the entire purpose. A clean, deliberate break in the supply. One quick note before we go on. Everything I draw here is in a free browser editor. No install, no sign up. It is at CircuitDiagramMaker.app, and the link is in the description. Open it and draw along. Here's the part that matters most. A proper isolator is double pole. It switches both the live and the neutral at the same time. Why break the neutral too? Because a fault, a wiring mistake, or a borrowed neutral shared with another circuit can leave that neutral sitting at a dangerous voltage, even with the live already open. Break only the live, and you are trusting a neutral you cannot see. Break both poles, and the circuit past the isolator is truly floating. Nothing left connected to the supply at all. That is the whole point of a double pole disconnect. It isolates completely. Now the terminals, and they could not be simpler. The supply comes in on one side, the line side, marked line, and it sits at the top. The load leaves from the other, marked load at the bottom. Live and neutral land on the two line terminals. Live and neutral leave from the two load terminals. The switch mechanism sits in between. Get that the right way round. Incoming supply on line, everything you are protecting on load. Line in at the top, load out at the bottom, supply to switch to load. Where does an isolator actually go? Two common spots. 1. A main isolator right before the distribution board, so you can kill the whole board in a single move. That is your main isolator switch. 2. A dedicated isolator next to one big appliance. A geyser, an air conditioner, a pool pump, a workshop machine. That local isolator lets you work on that one appliance without shutting down the entire house or plant. Same device, same wiring, just sitting in front of whatever you need to make dead. And this is why an isolator earns its keep. Lock off. A proper isolator has a hasp. Throw the handle to off, and you can clip a padlock straight through it. Now nobody can flip it back on while you have your hands in the job. That is safe isolation, lock out, tag out. You throw it off, you lock it, and you pocket the only key. A plain switch cannot promise you that. Isolate, lock it off, keep the key on you, and then work. A couple of choices when you pick one. For a single-phase supply, you want a double-pole isolator, 2 poles, live and neutral. For a 3-phase supply, you step up to a 4-pole isolator, 3 lives and the neutral, all broken together. Then size it. The current rating must match or beat the load. A small circuit might want 20 amps, a geyser 32, a bigger board 63 or more. And if it lives outdoors, a pool pump, an aircon condenser. It needs a weatherproof enclosure. An IP-rated box, so rain and dust stay out. Right poles, right rating, right enclosure. Here is what a clean isolator wiring diagram looks like, everything we covered on one sheet. Supply in on the line side. The double pole switch in the middle, breaking the live and the neutral together. The load out the other side. And the earth carried straight through, unbroken. Follow any wire, end to end. That is what a clear drawing gives you. Now let us lay one out from scratch. Blank canvas. I search the symbol library and tap parts onto the grid. A breaker for the incoming feed. A box standing in for the isolator. A load for the appliance. And a ground. These come from the free do-it-yourself pack the guest editor gives you. Then the wires. Press W, click one pin, click the next, and the wire snaps in with square corners. Move apart, and every wire follows. When the drawing is done, it has to leave the screen. One click opens the export menu. PNG is free, good enough to drop into a job sheet, or a group chat with whoever is doing the install. Vector formats, PDF, SVG, and DXF sit on the paid plans. Full disclosure, and I will say it plainly, this tool is ours. For clean wiring and schematic drawings you can share and mark up, it is genuinely good and free to start. So that is an isolator switch, start to finish. Double pole, it breaks the live and the neutral together. Line it on top, load out the bottom. It sits before a board or in front of one big appliance. And a hasp lets you lock it off so it stays dead while you work. One safety word, always work dead. Open the isolator, lock it off, and prove it with a tester before you touch a single conductor. Open the free editor and lay out your own. A breaker, the isolator, the load, a ground. It is at CircuitDiagramMaker app. No install, no card. Subscribe for a new wiring video every week. See you in the next one.